A multi-dimensional array can be thought of as an array of arrays, or an array of arrays if it's a three-dimensional array. When could you ever possibly need an array of arrays, not to mention an array of arrays? Well, think of a grid. Think of any old grid. Think of a chessboard grid. When you've got 8 squares horizontally and 8 squares vertically, now you might want to keep track of all 64 pieces on the chessboard. Now you could, if you wanted to, create a single array of 64 elements. Or you could create a multi-dimensional array. An array of 8 things, and each one of those things is an array of its own of 8 elements. So in other words, you'd have an array of 8 arrays of 8 elements, giving you 64 in total. Let's have a look in the source code and see how that works. This is multi.c in chapter 6 folder. I thought I might just build that exact example. Let's have a look at how multi-dimensional arrays are declared. Let's say it's an array of integers, or an array of integers if you like, and we'll call it grid. Int grid. Now, if I just did that, I'd get an array of 8 integers, quite clearly. Now, if I did that, I'd have an array of 8 arrays of 8 integers. Which way around is it? Is it that is 8 lots of that, or is that 8 lots of that? Do you understand the question? If it's a bit confusing because both numbers are 8, so I'll change one. I'll make this one 3. So, here's the question rephrased. Is this 8 arrays of size 3, or is it 3 arrays of size 8? That's the question. The answer is, this is 8 arrays, and each of those arrays is of size 3. So, let's think about it another way. We've got an array of 8 things, and each thing is an array of 3 integers. I hope that makes sense. Well, let's start coding this and actually see some coding examples of this. Let's pretend this is a chessboard, and we would need then to, well, we wouldn't really need it to be 8, but just for the purposes of clarity, I'm going to keep it as a chessboard that's size 8 by 3. And then we could make some statements like this. Grid 0, 0. Now that's obviously one of the corners. That's the first element of the grid, if you like. So is it the top left or the bottom right or the top right? Well, that's up to us to decide. We can say, well, okay, that's going to be top right. No, that's silly. Let's make it top left. Okay, so we can say in the top left we are storing a 1. Now 1 might represent, say, a rook. And then we can say grid 0, 1, and that might be a horse, so that might be a 2. We could obviously change this, and we could say, well, make it a char, and then those could change to rook and horse, and so forth. And we can continue on like that as long as we like. Now, let's say that we wanted to initialize every single element of the array, all 24 of them. We may not want to do it one by one like that. Instead, we could create a for loop. We could say for I equals 0, I is less than 8, I equals I plus 1, and now for j equals 0, j is less than 3 this time. So this is the inner loop that we're now working on. There's only 3 elements in this inner loop, which sounds right to us because we've got an array of 8 things and each thing is 3 chars in size. So I'll put them back to integers. And then j equals j plus 1. And we want to initialize it, we might do it like this. Grid I j equals 0. And that's a very standard piece of C code. That's initializing a two-dimensional array. And that's what you'd need to do. The only tricky bit is making sure that you get the I and the j round the right way. You wouldn't want to put the j here and the I here, because it would go all wrong. So putting it back to the correct way, how do we know that that's in fact right? Well, j is in the second spot and j is going up to 3. And we can see here that the second spot goes up to 3, while the first spot goes up to 8. So I goes up to 8, so I goes into that box. So there's a very simple initialization for you. Let's say we decided that this program is going to be a little bit more sophisticated. Let's make this program actually useful. Let's make it print out for us a times table. Let's say a 20 times table. Does 20 times table sound good? Okay, let's do a 20 by 20 array, just to make sure that we fully understand what's going on here. So obviously now this has to change to 20, and this has to change to 20. Okay. And what's going to be in each spot? Well, in the very first spot, we're going to have 1 times 1. Okay, fair enough. So what is 1 times 1? Well, it's really, in this case, I times j. Except, if you recall, that I and j are starting at 0. They're not starting at 1. So it's actually I plus 1 times j plus 1. So we would want to do this, I plus 1 times j plus 1. Now that's not quite right either. It's almost there. In fact, it's the right idea, but remember that multiplication happens before addition. So that multiplication there is going to happen first. We're going to get 1 times j. Whatever that is, we're going to add I to it, and then we're going to add 1 to it. So that's not exactly what we want. So we actually want this. So that should give us 1 times 1 in the very first square. Okay, so there's our initialization of the grid. Now it might be nice to print the grid out. Whoops. So let's do another set of for loops. In fact, rather than retype them, we pretty much know that those two lines are going to be identical. So we'll copy those lines and put them there. Now, what are we going to do? Well, I'd say each time through the outer loop we're going to print out a row, and that row is going to be that row of the grid. So each time through the inner loop we're going to have to print out the number itself plus a space. So let's try that. We're going to do a %d and then a space, and then, then that's going to be the number what? Grid. Well, I'm guessing it's going to be I, j, whatever we find at that position in the grid. Now, after we get through every inner loop, we want to print out a new line to move us on to the next line, so we get each line on a separate line by itself. So I'm going to do this. Okay. So in the outer loop we're going to do all of this 20 times. We're going to do those three things 20 times. So we're going to print out whatever the line of that particular grid happens to be, and then we're going to end it with a new line. So let's see if that works. I guess before we start, we probably should invent the variables I and j. They're going to be necessary. Int I, j, separated by commas. They don't need to be initialized because they get initialized here and here. Okay, and let's give that a go. Okay, so compile, no errors, and run. Whoa, that didn't look like what we thought it would. Clearly there's an error here. Can you see it? There, I've just given you a bit more room. Can you see it? Pause the video there and see if you can spot what's going on, because I'm going to tell you what's wrong in a second. But pause it just now. Okay, spot it? Okay, here it is. We've got a semicolon on the end of the line for the for loop. Now, obviously we've got another one there because I copied and pasted. Okay, now you have to ask yourself, did I put that in there deliberately or was that a genuine mistake? Alright, I'll come clean. That was a genuine mistake. even people who've been programming in C for as long as I have, that's 15 years, still make these mistakes. So let's try again. No errors again. Run the project. Oh, okay, that's starting to look a little healthier. Yep, 1 up in that column. 20 times 20 is 400 down the bottom. Excellent. Wasn't really formatted properly, but we can fix that up quite easily. Before we go on, while we're on the subject of that little extra semicolon, if I put that little semicolon back in, how would that affect the running of the program? Can you actually imagine how that would work? What would be the effect of that? I'll leave that as an exercise for you. Pull out multi.c out of the Chapter 6 folder on the CD, put the semicolons in, and see if you can figure out what's going on. It's a good exercise in understanding compilers. Anyway, I'd like to make this a little prettier now, make the output sort of in nice vertical rows and columns. So how might I do that? Well, what I want to do is I want to make sure that this number here is printed out in exactly 3 spaces, no matter what. I want to make sure that even if it's the number 1 or the number 400, it's still printed out in a column of 3 characters. And that's quite easy to do. You just do %3d. So let's try that. Okay, and run. That's much nicer. However, we're getting an extra blank line here, and the reason for that is this is an 80 character screen here. From there to there is 80 characters, and we're using every one of those 80 characters, and then we're putting in a new line. So it's wrapping an extra line around. If you can't figure out what I just said, don't worry about it. It's not particularly important. But I'd like this to be a little prettier. I'd like it to work properly. So let's, instead of doing 20, let's do, say, 18. We'll make it an 18 times table. Okay, let's just change that. I'll do that myself rather than waste all your time. Okay, back again. I've changed the 6 instances. 1, 2, 3, 4, 5, 6. Let's try it again. And we'll run it. Oh yes, now we're on the money. That looks excellent. Okay, so we never need to bother learning the times table again. We can just write a program to do it. All we need to learn is C. I can think of which would you rather learn? The language of C or how to multiply? I think I'd rather learn how to multiply personally. Although learning C does enable you to get a much higher paying job. So here is our working program. I'm going to save this as multi.c for you, and I'm going to move on now and show you another way that multi-dimensional arrays can be useful. This time we're not going to focus on integers. Okay, here's multi2.c. I'm going to now create another type of multi-dimensional array, and this is going to be an array of strings. Not an array of strings, like we had an array of ints before, but an array of strings. And if you remember, a string is a character array. So we're going to have an array of characters. It doesn't sound too hard. Let's have a look at it. Char strings, and let's say 10 brackets 20. Actually, let's not make it 10. Let's make it just 5. Okay, so 5 and 20. So what is that? Is that 20 strings and each one is 5 long? Or is that 5 strings and each one is 20 long? Can you remember? Well, the answer is this is 5 strings and each one of them is 20 long. The reason I'm showing you this as a separate example is that I want to show you that you can actually manipulate individual arrays in a multi-dimensional array. Let me show you what I'm talking about. I'll just finish my code in my own time. Okay, I finished my typing. Now, we're about to read in a string, so that's obviously %s. We're going to do that 5 times because we have 5 strings and each one is of length 20. Please enter your string, please, string number 1, string number 2, etc. What goes here? Scanf. What are we reading into? Now, the answer is either going to be really obvious to you, and you'll be surprised that I'm even asking the question, or you may find it a bit difficult. Like, have a think about it. What would go here? Well, the answer is this. It would be strings I. we're reading in the ith string, which obviously will be starting with 0, going all the way up to 4. So the very first time through the loop, we'll have a 0 there. We'll be reading in the 0th string, the first string, if you like. And that string will be 20 characters long. So we obviously want to make sure that the user types in no more than 19 characters on the keyboard. Remember? Now I'll just complete this program. I'll just do a little bit of more magic typing. Okay, I've just added the line that's going to print out all this code. String %d is %s. Okay, you can all see what that's going to do. It's pretty much just what we had before. Whoops, I forgot to put the I back in there. Okay. So we've got string number 3 will be, and then the third string. So that's the program completed. Why am I showing you this program compared to the multiplication table? Well, I'm showing you this program because I want you to see that it is actually possible to manipulate individual arrays inside a multi-dimensional array, like this. The same would apply to integers if there was such a piece of functionality in C that worked with arrays of integers. There isn't. There's obviously only one that works with strings, this %s here. We don't have anything that will, say, print out for us an array of integers automatically. We have to write the code for that ourselves. But this is the interesting part here. Strings is a multi-dimensional array, but I can just reference individual arrays in there. And I could even access individual characters. I'll just put one line of one printf at the end, just to show you how I do that. String %d character 2 is %c. So I want the second character out of, well, let's say string 2. String 2 character 2 is what? Well, it'll be something here. Something, something, something. Can you think what it might be? It'll be 1 and 1. Remember, you've always got to subtract 1. So the very first character in the array will be character 0, and the second character will be character 1, as you can see here. So the second character out of the second string is strings 1, 1. If I wanted to make it string 4 character 2, I would have to do it like this. Just verify in your head that that is exactly what it's supposed to be, and we'll compile and run this. So compile, no errors, run, please enter string 1. Okay. Hello there, name, mark, I can't even type my own name. Hello there, name, mark, virtue. Hello there, name, mark, virtue. Okay, that worked. Now string 4 character 2 is A. Is that correct? There's string 4 character 2 is an A. Excellent, so that's working. So that's the second and final example of multi-dimensional arrays. This is saved as multi2.c.